Welcome everyone, and thanks for choosing this session. I know there are a lot of other awesome sessions going on at the same time as well, so thanks for choosing this. My name is Deepu K. Shashidharan. I'm the co-lead developer of JHipster and open source aficionado, I like to call myself that. I work for a company called Zibia Labs. We are building enterprise DevOps software for cloud and containers. So you can find me on Twitter and LinkedIn. So if you like this talk, maybe you can check out my book. I'm writing a version 2 of the same as well. So let's get into business. So before that, my company is paying for me for the trip, so I have to talk something about my company. So we build enterprise DevOps tools. We have release orchestration and deployment orchestration tools, mostly geared towards enterprise, so that most of the stuff, annoying stuff that you don't want to deal with when setting up your DevOps infrastructure, that can be taken care of by the software, like the process, auditing, reporting, and those kind of things. So if you're interested, you can check out the website for that. So just so that I have some idea of what the audience are. So how many of you are Java web app developers? Okay, most of you. And how many of you are actually doing microservices? Okay, not bad. And any cloud native developers here? Okay, we have a few. Nice. Anyone who has already tried Istio or Linkerd, something like that? Okay, 2. And how about Kubernetes? How many of you are familiar with Kubernetes? Okay, so I think I don't have to go into basics of Kubernetes, right? I think most of you know the basics of Kubernetes and like what Kubernetes is, right? I would assume. Can I make that assumption? Yeah? Okay, how many of you have tried or heard about JHipster? Okay, not bad. Since that seems like many of you are not familiar with JHipster, so I'll give a very quick introduction, so that especially for the ones who are not familiar. So it is one of the most popular rapid application development platform for Java, web, and microservices. So it has quite a good presence in GitHub with 15K plus stars, more than 25K projects on GitHub which uses JHipster, more than 500 contributors on GitHub. It has more than 2 million records so far, installations so far, and every month there is on average 20,000 applications being generated. This is based on the anonymous stats that we collect. And we have more than 250,000 registered users on our website and stuff. And there are more than 300 companies who registered claiming to be using JHipster. So we have a lot of plugins and stuff. So it's quite a active and vibrant community. So what can you do with JHipster? So obviously you can world peace, fix your plumbing, these kind of things. This is what we are aiming for. Not there yet, but definitely in our backlog. So what JHipster can do now for you is it can build simple monolithic web applications for you, like full-fledged, production-ready with testing, unit testing, integration testing, Sonar integrations, whatever you would normally require to get up and running on a greenfield project, for example. It can create complex microservice architectures. That is something that we would see today. It can create entities and domain models for the applications, either monolithic or microservice. It can do that for you. It can create CI/CD pipelines for you based on whatever tools that you use. It can create deployment plans and deploy to AWS, GCP, Azure, Heroku, Cloud Foundry, and so on. It can also deploy to Docker, Kubernetes, and OpenShift. So it's like whatever you would normally want to do in a development pipeline, JHipster can do that for you. So it's a full-fledged platform. You might ask, I mean, if it is scaffolding, isn't it just some boilerplate junk code that is generated that probably you wouldn't want to refactor and throw out, right? For that, I would want to show this. So this screenshot is from the homepage of Sonar Cloud. So they have a section called featured applications where they feature application with very high quality based on their analysis. And there are 2 JHipster applications on the homepage. So the first one is a sample that we auto-generate during each of our release. And the second one is an application built by Matt Rabel. He has a mini book on that. You can check that out if you're interested. But you can see the code quality, right? How many of us can claim that we would have similar code quality when we are doing something from scratch? Like AAA rating for bugs, vulnerabilities, and code smells like this kind of code coverage and like soulless duplications and stuff. So it's not some junk code that is being generated. So it's highly crafted, production-ready code that as good as if you have written it yourself, like from scratch, because it's like around 500 people sitting and actually writing code and making them into templates and making sure that regardless of what options you choose, the output is as good as what you would have written yourself. So let's get into business. So we are here to talk about building microservices. So that was just the introduction to give you a background. So before we start, let's start with a use case example, right? So let's assume that we want to build an e-commerce website as a microservice, right? So first, what we will do is first we will see how we can build this microservice use case in a traditional manner, not going cloud native or anything, using a more traditional approach, and then we will see how the same can be done with a cloud native approach and what the differences are. So for the traditional approach, we can go with Netflix OSS because it has been around for quite a while and has been used for traditional microservice use cases for quite a while. Because before cloud native became a huge thing, everyone was using the Netflix OSS tool suite to build microservices. Of course, there were others, but these were some of the major players. One second. Yeah. So the libraries from Netflix that we would normally use in a traditional microservice implementation would be Eureka for service discovery and to be used as service registry. We would use Ribbon for load balancing, fault tolerance, caching, batching, these kind of things. We would use Hystrix, which is a circuit breaking implementation, and we would use it for circuit breaking and fault tolerance. We would use Zul as a edge service normally. So this is a typical Netflix OSS-based microservice implementation. This is how it would look like. And for an architecture, in JHipster, you can do that in JHipster as well. If you do the same implementation in JHipster using a traditional Netflix-based libraries, it would look something like this. So we have a microservice implementation of e-commerce website. So we have a gateway which kind of serves the client side and also routes all your requests to appropriate microservices. So we have a product service, an invoice service, a notification service. So all these three services together makes your e-commerce website, for example. So we have something called JHipster Registry here, which takes care of service discovery, cloud config, administration, metrics, and these kind of things. And we have something called JHipster Console, which is for telemetry, which is nothing but a wrapper around Elastic Stack and Zipkin to provide a telemetry option. So, yeah. So JHipster Registry we saw earlier, like the one on the left, is composed of 4 parts. It has a Eureka server so that it provides service discovery. It has Spring Cloud Config Server also integrated, so it provides runtime configuration management service for the architecture. It also has custom-built administration server so that it provides monitoring, logs, dashboards, and stuff like that. Stuff that is required when you have a complex infrastructure up and running. It also has Spring Boot as the base to run as a standalone application. So this is what JHipster Registry is made of. So this would have been a traditional approach of doing microservices. One example. Of course, there are a lot of other ways to do it as well. This is just one example. And this particular architecture need not be cloud. This is not cloud native. This can be deployed wherever you want. This can be deployed to Docker setup, for example, or you can run it on your own JVM manually using some sort of setup, or even as plain JVM applications. They are all Spring Boot applications, so you can just Java-jar and run them as well. But I'm pretty sure in production nobody would be doing that, right? You would have some sort of infrastructure. So you can of course deploy to Kubernetes. So this is all possible, but it is not cloud native. Even if you deploy this to Kubernetes, this architecture is not going to make advantage of any of the Kubernetes features, right? it is just going to use Kubernetes as like a VM to run this, like a host your JVM, and then just runs off the JVM, right? So this is where the cloud native approach comes in, and this is where especially Istio comes into picture. So of course you can implement the previous architecture. You can, when you deploy it to Kubernetes, you can make some changes here and there to make it more cloud native. Say for example, you can try to make use of the Kubernetes routing instead of Zul. You would have to rewrite a little bit here and there to integrate some Kubernetes APIs, and then you can get routing from Kubernetes, for example. So it can be done, but then again, it would be a lot of stuff that you have to do yourself. It's not like everything is given to you and you just concentrate on building your application. That is what we are looking for, because we shouldn't be spending our time writing infrastructure and writing glue code so that the infrastructure works and everything. We should be concentrating more on writing our business logic, right? So there should be something that takes care of all this. So Kubernetes takes care of the infrastructure to an extent, but when it comes to microservices, still Kubernetes doesn't do everything for you. It only does a handful of stuff. There are a lot of things that you still have to do. So those kind of things are something that developers need not worry about. This can be easily offloaded to a service or something else, right? So that is where Istio comes in. So it's Istio kind of today. Istio is one of the coolest kid on the cloud native block. It's a service mesh, meaning it provides a lot of lot of features that a traditional microservice implementation normally requires. We'll see a little bit more on that. So Istio is designed for distributed applications, and it plays very well with Kubernetes. It is not part of Kubernetes. It is a separate product which you have to install into your Kubernetes cluster. But still, once you have done that, it almost feels as if it is part of Kubernetes. It is so well integrated with Kubernetes. Most of the major cloud providers like Google, Azure, Amazon, they all support Istio already. So it's a great way to get into the whole cloud native microservice strategy. So these are the features that Istio provides. So it provides service discovery. So basically, you can replace things like Eureka or Console using the service discovery provided by Istio. It can do automatic load balancing. So that means you can replace some stuff like Netflix Zul, for example. It can do routing, circuit breaking, retries, failovers, fault injection. So you can replace a bunch of other libraries as well, like Ribbon, Hystrix. You can replace all that with Istio. It gives you policy enforcements. So that means you can enforce really complex policies on your servers for whatever reason, maybe for rate limiting, for example, right? There are a lot of things that can be done with policy enforcements. You can do access control management, rate limiting, A/B testing, traffic splits, quota management. You know, if you have customers for whom your product gives quotas, you can actually manage that using Istio. You don't have to write any service or anything within your application to do that. You can just do it with Istio policies. And you can do easy A/B testing with Istio. You don't have to have a A/B testing strategy or a complex DevOps tool to orchestrate that for you. You can just do it with Istio. So it is all possible. And on top of that, it gives you telemetry, metrics, logs, traces, and all these things. It has secure service-to-service communication, and that part you can use a lot of different, say for example, you can do HTTP, gRPC, like there are a lot of implementations that you can use. This is just a handful of Istio features. There are even more features, but those are minor compared to these, so we are not going there. So before we go see the architecture and before we start the demo, for those who are not familiar with how Istio works, I'll try to summarize a little bit. I'm pretty sure this is not going to give you everything about Istio. The idea is not that from one conference talk you become an expert in something. The idea is to introduce something, and if it makes sense, if it kind of interests you, then you go check out more, and you kind of become an expert or like whatever, right? So the idea is to introduce the thing to you. So Istio architecture can be simplified into having two planes. So Istio has a data plane and a control plane. So the data plane is actually made of envoy proxies. The data plane is one on the bottom. So that is where your applications will actually reside. And Istio, the Istio part in this plane is the envoy proxies and the ingress and egress controllers. So this is what Istio is interested about. So you can configure Istio to auto-inject envoy proxies to your containers as a sidecar. So whenever you deploy your container, Istio will inject a sidecar as which is just an envoy proxy. So envoy proxy is nothing but a lightweight, high-performance proxy, distributed proxy written in C++. So it is really fast and really lightweight. So Istio just attaches a copy of envoy proxy, an instance of envoy proxy to each of your container. So if you look at a pod with Istio, you would see two containers in the pod, your application and the envoy proxy. So what it means is that everything that happens with your application, so any communication, any network traffic to your application goes through the proxy. So you can see where it goes, right? So when you have a proxy before your application, all the in-out traffic is controlled by the proxy. So that means Envoy has total control over that particular application. That is how it is able to, enforce policies, for example, do A/B testing or whatever. So that is how. So Istio makes heavy use of Envoy proxy. So that is the core of what Istio does. And also you have the egress and egress controllers for in and out traffic from within your cluster to outside and outside. The top part is the control plane. So that is where the Istio components reside, or things, the brain resides. So it uses a component called Pilot, which provides service discovery, which is in charge of traffic management, resiliency, and these kind of things. So Pilot is responsible also for configuring the proxies. So it tells the proxies what to do and when to do it. So that is why the name Pilot. So it pilots everything. It also configures something called Mixer, which is also responsible for enforcing policies and collecting telemetry. So it also has other components called Citadel, which manages security, and another component called Galley, which manages configurations. So when you download Istio, it comes with a demo installation setup, which can actually install pre-configured instances of Grafana, Prometheus, Kiali, or Jaeger for monitoring and traceability. So that's an optional thing. So when you install Istio, you can choose to install those components as well, or you can, if you already have your own setup of any of these monitoring tools or many other things that Istio supports, you can also configure Istio to stream all the logs to your existing monitoring setup. That is also possible. So I hope this makes a bit sense. So demo time, so it's better to show than to explain, right? So you can also find the demo as a blog post on this URL if you're interested. So there are some prerequisite. You can also try it out if you have a laptop and if you want to go along. This is quite fast to do, so you can also try it out if you want. So we would need a Kubernetes cluster. I'm using GKE for this example. You could also use the Azure Kubernetes service, or Amazon one, or your own Kubernetes cluster. The only thing is you have to make sure that you have you install Istio on top of it. For this example, I'm using Kubernetes version 1.13. Few things to note when you create a cluster. The important parts are the number of nodes. For this particular example that I'm doing, it at least needs a 4-node cluster, that is the minimum, and it needs a machine type of N1 standard 2 in GKE, and or similar in other services. So I think this is the probably tier 2 processor, probably not the lowest one, because the lowest one probably wouldn't work, because I'm kind of going to run like 4 services and like a bunch of monitoring tools and all of this. So you need some horsepower to run all these. So I already have created the cluster, because in my last demo, similarly, I was so foolish enough to create a cluster on stage from scratch and messed up everything. So I was not that foolish today. So I already created my cluster. Yeah, so I already have my cluster. So the next thing is installing Istio on your local machine. I have also done that already. You can do it if you like. And next, we need to make sure our cluster can work with Istio, because Istio is not part of Kubernetes. It's an add-on. So the first thing is you need to install Istio onto your Kubernetes cluster so that when you deploy applications to Kubernetes, Kubernetes knows what to do with certain things. It knows how to handle the Istio related stuff. So Istio has its own custom resource definitions. Those are like similar to, say, for example, in Kubernetes, you have a stateful set, right? So the Istio provides similar types, kinds, but custom, its own kinds. So you can use an Istio kind in your deployment manifest. So for those kinds to work, you have to first install those particular CRDs or custom resource definitions into your cluster. So this is, ideally these are supposed to be like transparent, unless you are diving deep into writing your own resource definition or customizing something. You shouldn't be bothered about this. You just install what Istio gives you, follow the instructions, install it on your cluster, and then you worry only about your application. You shouldn't be worrying about these things, ideally. So let us start. I'll mirror so that. Yeah. Okay. So let me. So we need to first. Is the font size okay, or should I make it bigger? Yeah. Okay. So first we have to install certain cluster role bindings. So here we are installing cluster role binding for and assigning it to a user. So okay, I think there is something wrong with what I pasted. Yes, I know. This always happens. This happened to me last time as well. The nodes, for some reason, adds empty lines. Okay, so the role binding is created. Then we would create a namespace. So this is for Istio. So we can also call it another namespace. Just make sure you use the same in other places as well. But it's quite straightforward to just say Istio system. And that is also the default one that Istio creates. If you don't use Helm or anything, and if you do install Istio using the options provided by your Kubernetes service provider, then it is also Istio system. So then we would actually use, let me go to my Istio installation, Istio 1.3. So from my Istio installation, which I already downloaded, I'm going to install the Helm charts. So the first one installs all the CRDs or our custom resource definitions. So once the CRDs are installed, we can actually check. There needs to be 23 of them. So this is a validation that we could do. So it's not there up there yet. So 23. So there are 23 CRDs that Istio provides. So we have installed all of them. The next is to actually install the Istio components like Pilot, Citadel, and also here you can see in the Helm templates I'm using the Istio values Istio demo, which is a particular value set which also provides Grafana, Prometheus, Keali, and Jaeger, so that I don't have to configure them myself. I can just get what is provided by Istio and use it. But one disadvantage of going with the demo Helm chart is it's not optimized. Say, for example, it doesn't have any resource limits specified in the manifest. That means it is going to take a lot of your CPU and memory. So if you look for a realistic setup, then probably it's a good idea to maybe take it, but customize it to optimize it further. Customize the resource requirements like memory and CPU requirements. So make sure that it uses your cluster more effectively or efficiently. So this probably will take a second. Okay, so still starting up. So we are interested in only one service, for example, kubectl get ports -n Istio system. Okay, so some of the services are still not done. Okay, I think they are more or less ready. So we would now be interested in getting the services so that we can get an external IP. So the only thing here that is exposed would be your ingress gateway. And as soon as your ingress gateway has an external IP, it's ready for you. So the system is ready, and we can proceed further. Okay. Okay, let's see. So we also have to export this for future use. So I'm exporting this IP for future use. So I can use it in other commands when required. Just a utility thing. Okay, let's get back into your presentation. Okay, so we saw this. So the Istio pods are already created in our cluster. So our cluster is now ready with Istio. So now let's look at the architecture, the same application architecture, but with Istio. You can see there are some differences. You have an ingress gateway now here, which becomes the entry point. In the previous architecture here, you see that the entry point is your gateway application directly. So all traffic comes to your gateway application, then it kind of distributes or routes the calls accordingly. But here, everything comes to your ingress gateway, and ingress gateway actually does the routing, which Istio takes care of. Istio makes sure it can route any incoming call to the appropriate microservice, including your gateway, which is still serving your front end, right? And instead of a registry, we now have the Istio control plane, which takes care of service discovery, circuit breaking, authentication, security, telemetry, and so on. And we have a monitoring setup which is provided by Istio itself. We have Grafana, Prometheus, Jaeger, and Kiali for monitoring and observability. We'll see a little bit more about those tools later. You can see that each of the microservices has its own database and everything. So this is quite heavy, actually. So you have 4 Spring Boot applications, 4 databases, each of them having their own database, and then there are like at least 4 applications from Istio, like Citadel, Galley, Mixer, Pilot, and then you have like 4 or 5 of the monitoring applications running. So this overall is a very heavy setup, right? So there's a lot of applications there. But the only things that you would manage or that you would be interested in would be your gateway, your product, invoice, and notification. All other things will be handled by Kubernetes and Istio. So it should be ideally transparent to you. Of course, that doesn't mean that you would never have to think about them. Of course, in a real world scenario, you would always have to fiddle something with those, and they will always drive you crazy one day or the other. So before we start building our application, so how we are going to do it is, we are of course going to use JHipster to scaffold everything. But to make it even easy, JHipster has something called JDL, or JHipster Domain Language. It's our own DSL where you can define applications and deployments, entities, and stuff like that. So we'll be using that. Yeah. So is it big enough? Yeah, is it visible enough? At the back, is it okay? The size? Yeah, okay. So this is what the JDL looks like. So you can basically define applications, you can define entities, you can define, say, enums, relationships between entities. You can have some properties defined as well, like to have a service layer or not, to have paginations or not, some stuff like that. And you can also define deployments. So this is what JDL is. So for example, so this is our gateway application definition. So in a config, you say provide certain parameters. You provide a name, you provide a type of the application, of course, the normal stuff like package names. You can enable service discovery. In a traditional setup, you will enable service discovery with Eureka or Console, which are supported by JHipster. But since we are going to use Istio, we can disable this part. We don't need native service discovery. So we turn it off. And authentication type, you can choose between JWT or OIDC, for example. You can choose any of the supported database, MySQL, Oracle, MS SQL, MariaDB, or non-SQL databases like Mongo, Cassandra. There's a lot of supported databases. You can choose from any of them. You can specify cache providers, for example, so that all your service layer, your domain layer will be cached as well for better performance. You can choose your build tool. You can choose between Gradle and Maven. You can also choose a client framework. Since this is a gateway, it needs to have a client for you to come and interact. So you can choose between React, Angular, or Vue. So accordingly, it will create a client based on any of these framework for you. You can use SAS on the front end, for example. You can use test frameworks. So currently, I think we have Protractor, Cucumber, and Gatling supported. So you can choose all three, or you can choose just one. I'm just choosing Protractor for example. And then you also say that this application uses all the entities defined, because this is the gateway. So it needs to generate front end for everything, even for the entities that are on your microservices. Because we are in the JHipster architecture, we kind of use a monolithic approach to front end. We don't have micro front ends. We put all the front ends in a entry application or a gateway application, which is also one of the approach. You can also go micro front ends if you want, but then you would have to do it yourself. Similarly, we are defining the remaining applications. So this is a product application, which is of type microservice. That means we don't have to define a client side and stuff like that. You might want to provide a different server port so that there is no port clashes. So because the default is 8080, so I'm incrementing them here. And similar options here. And only the entities that is required by this particular microservice is being tagged here. Similarly, there's another microservice called Invoice, similar options, and its entities. Then finally, there is a notification service, which is using MongoDB instead of MySQL. The others were using MySQL, and it has one entity as well. Once the applications are defined, you can define your entities. So these are more JPA-like entity definitions. So you basically say the name of your domain POJO, the fields, type, and some validation rules. So that's it. You can also define enums. And once you have your entities defined, you can define relationship between entities. So this, of course, depends on what kind of database you use. So if you have chosen any of the SQL database or MongoDB, then you can do relationship. But if you choose Couchbase or Cassandra, you can't do relationships because of the database models. So in a relationship declaration, you can say if it is one-to-one or many-to-one or whatever. You can say the to side and from side. You can also say by what fields they should be related to, and you can say if this required relationship or not. Yeah, the syntax might look a bit complex, but we have documentation explaining how it works and all those things. So and that's not the important part for today. You can also have some properties for the entire application. For example, you can say a particular entity needs to have a service class or a service implementation, or you can say no service, directly use a resource to database kind of connection if it is too simple. So that's up to the architectural choice. You can also enable pagination for entities, like you can say you want to have an infinite scroll kind of pagination, which is more of a front-end implementation, or you can say I need simple pagination with pagination links. So we have entity definitions we have quite a lot of entities here. Yeah, so you can actually see from this generated UML-ish kind of diagram that this is the schema that we have. So we have a customer, which is related to user. User is an inbuilt entity. That is why you don't see any properties. It's already provided by JHipster, so it just has a relationship there. You have the product-related stuff. You have the invoice-related stuff, and finally the notification thing. Since we are doing microservices, we don't have any hard relationship between entities of different services. If at all, when they are required, you make soft relationships. Otherwise, you're not doing microservices, right? You're creating tight coupling there. So finally, we also have a deployment defined here. So we say for deployment type, you can use between Docker, Kubernetes, and OpenShift. Those are supported. And also the other cloud stuff like GCP, those kind of things. So here we are going with Kubernetes. We say which are the applications to be included in the deployment. The Docker repository name to use, I'm using my personal Docker repository. Again, no service discovery required because we are using Istio. Yes, Istio true. Kubernetes service type. When using Istio, it is very important that we use ingress because Istio needs an ingress controller to do the routing and stuff. So ingress is mandatory. Kubernetes namespace is optional. I'm just using one so that it is easier to categorize stuff. And finally, ingress domain is also quite important because when you say that it is ingress, you also have to provide a DNS for that. So I'm doing a neat trick here to make sure that, one second. For example, so this is the IP that I got from the Istio ingress controller that we just created. So what I'm going to do is, I'm going to use that IP and use a wildcard DNS provider. Don't do this in production. This is not secure at all. Using stuff like NIP.io, those are wildcard DNS providers, but they are not secure. They are okay for demonstrations and these kind of things, but they are not secure. So if you're doing a real thing, register a domain and use that as your DNS. So for now, I'll just use that. So I'm going to save this into workspace, JHipster, temp, Oracle code 1. So I'm going to call it app.jdl. Yeah, I think I already wrote one there. Okay, so we have our app.jdl. So now it's quite simple. Let's, oops, present. Yeah. For example, by the way, the JDL is also available on this URL, if you like. The references are found in our website for the JDL as well. So we just need to run a command now to get everything up and running. So let's get to it. So we say JHipster import JDL, that's a command, and provide the file, and sit back and JHipster will do its magic. So what JHipster is doing now is it's actually parallelly creating applications. It is generating all the applications simultaneously. It is doing steps like doing npm install on the client-side application, for example. It is doing a webpack build on the client side, for example. So once all the applications are done, it will print out some useful information like what to do next or what commands to use for what. For example, like what commands to use to run your application and stuff like that. I think the most time-consuming part of this process is the npm install on the client side because it needs to download the internet, which is quite fast for this network, not bad. So we are done. So you can see that it created everything. It created all the applications. Then it also went ahead and created all the Kubernetes related stuff. It created manifest files for all of our applications. We'll look into that. And it also gave you some useful commands to, or what to do next. So the next steps would be to build our images for each of the application, then tag and push them to Docker, and then just deploy to Kubernetes. So this would be the next step. So let's take a quick look at what was generated. I hope I have the time. So until when do I have? Sorry? 6 more minutes. 6 more minutes. Oh, okay, that's not a lot. So very quickly. Okay, I'm just going to run the deployment first and then go through the code so it's fast. So cd store and build. Oops, not this one. Don't want this. Okay, here. cd product and build and cd invoice and build, and I think I also need to build notifications. Whatever. Come on, my shell. Okay. I decided to do something. cd notification and build. So we are doing a Webpack build of all the generated applications. And let's wait for that to finish. So in the meantime, so these are the applications that were created. So I'm not going to go into the code because you can just reproduce this yourself in your machine if you just have npm installed, like a node installed, because JHipster is a node library. So you do npm install -g generate a JHipster and you have it. You download the file, you can run it, and you can see that in your own machine, and you can go through. And these are Spring Boot applications, so they kind of follow the traditional like folder structuring and all those things. So you have your Java code here, AOP stuff, your config management, all the domains, repositories, security, service, all those things. And so this is the microservice, so that doesn't have any front end. You can also see it has some Docker stuff, but we use we don't use Docker builds directly. We use Jib, which is a Google library for managing Docker builds. We use that integration in Gradle or Maven to build Docker images. But regardless, Docker files are also provided. And resource which has configuration files, your I18N files, static files require templates and stuff like that. And all the other required stuff like a build, package logs and stuff. And in the Kubernetes folder, you can see it has created deployment YAMLs for your application, destination rule, which is for Istio. And this is deployment for your database, service for your application, virtual service, again required by Istio, secrets. Then Istio specific stuff like Grafana gateway, Jaeger gateway, and Kiali gateway, so that all these three tools can work with our setup. This is for the notification application, similar manifest files, similar for product, and similar for store. For store, I think there is an additional, no, it's the same. And there is a handy SS script to apply everything in one go as well. So in the store application, for example, which is gateway, you would have additional stuff like Webpack configurations for the client side. You would have the web app itself. Here I'm using React, so it's a React web app. And in all of the generated application, you would also have tests generated. You'll have Java unit and integration tests generated. And if there is JavaScript, it'll also have E2E and Java unit tests also generated. So the test coverage in generated applications is normally 80% or a bit more, 81% kind of thing. It's a default test coverage for the generated applications. So let's see. So all the builds are successful. Let's quickly tag and push them. Okay, I probably have it already. So Docker image tag product, and here let's do Docker image tag tag invoice. No, notification. Invoice, tag invoice, Docker image, Docker push. So invoice is done, notification is done, product is done. What is missing? What did I miss? I missed something. Store. Yes, I missed store. So yes, so all this is pushed. Only store needs to be pushed. So let's wait for that. In the meantime, let's see if, so the next step would be to Kubernetes apply. So kubectl apply for that. So everything is pushed and ready. So let's do a kubectl apply. So let's cd into the generated Kubernetes folder and do a kubectl apply. So it's creating all our applications. Yep, so it has also printed out some useful URLs for us. So we would need this. In the meantime, let's watch what's happening with our workload. So let's say kubectl get pods JHipster. So that's the namespace we use. So pods are starting. None of them are ready yet. So it's going to take at least 1 or 2 minutes for them to be up and running. So yeah, next is actually seeing the nope, not there yet. So let me put it in a watch loop. So as you can see, like in our generated files, there is also, for example, for the store in the destination rule, you can see that Istio created all the rules like traffic policy. It has set up a load balancer, it has set up connection pools, it has set up outlier detection, for example. You can add a lot more into these. And there should be a destination file from Istio somewhere. Yeah, store gateway. So since store is a gateway, here Istio configures the routing. So it says how to route to each application. So anything that has this prefix is routed to invoice. Anything with this prefix is routed to notification, for example. Right? So it configures those as well. So our applications are ready. So we can, let's say, store. Okay, it's still not ready. I thought it was ready. Let's give it a few more seconds. Store looks ready here. Unless I messed up the. No, it's ready. Probably needed a second. So this is the application. We can log in with the default admin, for example. Yeah, so you can see all the entities. Most of the entities are coming from microservices itself. For example, product category comes from the product microservice. We can already create one, for example. So this is actually, so it is actually being routed through the product microservice now from the gateway application. Similarly for other stuff as well. There are some administration screens like user management, some metrics and health and configuration, which comes from Spring Boot and Actuator. We have a nice UI on top of those. You have multiple language support, for example. So this is on the generated application itself. Now, things that we are a bit more interested would be the telemetry part that comes by default. So here, okay, so let's see Yager, for example.
You need to wrap this up so we can bring in the next session. Thank you so much.
Okay. Yeah, so basically you will have Yager here, you have Grafana for monitoring, and Grafana for monitoring, and Kiali for service visualization. So I wanted to show a bit more of how these things interact and stuff, but yeah. Yeah. Thank you, everyone. Yeah, sorry for taking long. Thank you.